How are you, everyone? Good afternoon. You're late. 5 minutes. You're not late. Our class starts at 50, not 55.
We have grace. 5 minutes.
Okay, so we are almost done with quadratic. The last thing from section 5.5 and 6 we didn't do is the reverse direction. We have a parabola, how to find the equation. We're going to do that. And then you are going to go for linear, nonlinear inequalities. Any question before you start? Comments, concern, complaint? No? So to find the equation, we start with the vertex form, which is y equals ax minus h squared plus k. Here, h and k is the vertex, a is the leading coefficient. So we see we have our vertex is at 1, 2, 3, 2, -3. In 2, -3, 2 is the h, -3 is the k. So we can replace h and k into this vertex form. We don't know what is a. Our goal is to find a. So to find a, we just need to replace x and y. So we can replace x and y with any xy value from this parabola. My favorite one is the y-intercept. You can take the y-intercept, or you can take any points that has a whole number x, whole number y. So if you take the y-intercept, our x value is 0, y is 1. We can replace this x and y with the y-intercept. So y is 1, a we are looking for. Our x is 0, our h is 2, and our k is -3. So you're replacing x, y, h, k. The only thing we don't know is a, so we solve for a. So we get 1 equals a -2 squared minus 3. Now to get the a alone, we need to get rid of the -3. So add 3 to both sides. We get 4 equals, what is -2 squared? 4. And then the last thing we do to get the a alone is divide by 4. The a is 1. Once you know the leading coefficient, we have to rewrite the equation. So we rewrite y equals a x minus h squared plus k. We are going to replace a, h, and k. So a is 1. We write 1 here. H is 2, so we write 2 here. And our k is -3, so we write -3 here. And that's it. This is our equation. Not always the leading coefficient will be 1. Sometimes it's other numbers, like 1/2 or 2 or 3 or 1/3. We always have to find what's the A. And H and K is always given to the parabola. So in the final exam, sometimes they give this question, not always, but sometimes. Any question? I really wanted to put this in the exam, but I don't have space. So I'm not going to give this in the exam. I'm going to leave it. Maybe you see in the final exam. Maybe you won't see in the final exam. Any question before you move on to 11.4? So 11.4, you can do 2 ways. Either you can use graphs or you can use number line. So my plan is to use graph for parabola, and for other question, which is not parabola, is the number line. In that way, you'll save you time during exams. Now, the difference between all this time, whatever we did and what we're going to do is that so far, when you solve for X, we got either no solution, 0 solution, 1 solution, or 2 solution. Oh, sorry, 0 solution means no solution. Either you get no solution, 1 solution, or 2 solutions. Now, when you solve inequality, we don't get a limited number of solutions. We get a set of solutions with many, many numbers. These numbers could be whole number, fraction, decimal, anything. There's a set of entire interval as our solution. And one thing we must see is that 0. If you have 0, you can figure out what you're looking for. For example, we have a quadratic equation here, it's less than 0. It means you're looking for something negative. Here, so something negative or something equals 0. Here we are looking for this quadratic strictly less than 0. Here we are looking for this quadratic bigger than 0 or equal 0. So we have 4 types of inequality. I didn't have space for another one, but the 4 types are bigger than or equal 0, so less than or equal, bigger than or equal, strictly less than, strictly bigger than. Whichever side has the mouth, it's bigger. So this side is big, and this pointy side is small. The mouth is always bigger than your butt, the pointy side. And depending on what we have, we use different boundary. Like for example, if you have the equal sign in your inequality, we use brackets, square brackets. But if you don't have the equal sign in your inequality, our boundary for the number line, the interval, has to have parentheses. Okay. Now, if you don't want to use graph, we must use the number line to check each interval in the number line. And then whichever simplify what you're looking for, we take those in the number. We take those in our solution. So how we do, first step, let's do some example and then you'll see. The solution, what we do is, let me see my R. We observe the Y's and solution gets the X. Based on what type of Y we have in our solution, we don't write the Y's, we write the X's as the interval. For example, let's say they're asking X squared is bigger than or equal 0. So x square, it's a parabola. Bigger than or equal 0 means where do you see all the y values are positive? I don't have space, so let me write it here. Y is strictly positive or y is 0. We look at the region or the portion of the graph where we have y positive or y 0, and then whichever x values give us those y's, we put them together in an interval. Example, y equals x squared is this graph, and this graph is positive or 0 everywhere. It's positive everywhere, 0 at the origin. So the solution for these y's are the x values. We have negative into positive infinity. Entire number line gives us all the y's, positive and 0. So we have negative infinity to positive infinity. So we observe the y's, but actually we get the x values that give us those y's. The x hmm? The x value will not have negative infinity to positive infinity. So here for every x value we have in our number line, every y is positive. The solution is from negative infinity to positive infinity as our x values. Oh, that's like the domain, like domain, but not domain. Yeah, solution and domain are similar concept, but domain means why it's valid. And here solution means which satisfies this condition. Y is 0 or y is bigger than 0. Because it's square. Positive. So we have y is positive here, and y is positive here, and y is 0 here. So entire parabola satisfy what you're looking for. That's why we take the entire x values, negative to positive infinity. Bracket is only for numbers. Infinity is not a number, it's a symbol. So for symbol, it's always parentheses. But for numbers, if you have a number, then it gets the bracket. For example, something like this. We're not going to have infinity as our solution. We are going to have a set, a portion of the number line as our solution. So for quadratic, I'm going to show you the graphing method. For non-quadratic, I'm going to show you the interval, the number line method. But yes, you can use a number line for quadratic as well, but it takes time. So let's graph negative x squared plus 4. So if you observe A and B, they actually have the same. Negative x squared plus 4, negative x squared plus 4. The only difference we have here is what you're looking for. Bigger than 0 is what you're looking for. Which type of y we are looking for? Positive y. Strictly positive y we are looking for. But in here, we have x is less than 0. So which type of y you're looking for in B? Strictly negative. They have the same question, but in one part you're looking for strictly positive, and in another part you're looking for strictly negative of the y. Now let's graph it. Negative x squared means what? Upside down. And we have a plus 4 after the square. So which type of transformation? Left, right, or up, down? Which one? Left, right is inside your square. Plus 4. Up 4. Negative means upside down, and then you have a 4 after you square. A number after the square means up, down with the correct sign. Plus means up, minus means down. But if you have a number inside the parentheses, it's left, right, opposite direction. Minus should go on the left, but it goes on the right. Plus should go on the right, but actually goes on the left. So left, right is inside, opposite. Up, down is outside, same. So what do we have? The original parabola is here, x squared. And we are taking its transformation, which is upside down and 4 units up. So 1 up, 2 up, 3 up, 4 up. 4 up here, and then upside down. And in the exam, you have to sketch. So you have to graph it, not sketch it. That means we need to know exactly where we are crossing the axis. So let's find the x-axis, x-intercept, because we need to know what are these numbers, where we are crossing. So finding x-intercept. Do you remember how to find x-intercept? Good. Set y 0 and solve for x. So we have negative x squared plus 4 equals 0. And then, we can subtract 4, or we can just add x squared. It will become positive. Either one is fine. So 4 is x squared. And then we take the square root. So we have x is. But how many x-intercepts you see in the graph? How many x-intercepts you see in the graph? Then how come you only one of them? See, you already forgot your plus minus symbol. Anytime you take the square root of a variable, you first have to put plus minus for the number. So you have 2 x-intercepts. One is -2 and one is +2. And now our graph is perfect. Our y-intercept is 4, x-intercept is plus and minus 2. And you're looking for the region, the area where the y is positive. So let's see. Let me change color to purple. In this area, what is your y, positive or negative? Negative y. And then in this area, what is your y, positive or negative? Negative. And in this middle part, what is your y? Positive. And which y you're looking for, positive or negative? Positive. So this area is positive. So we are looking for which x values gives us these y values. So which x values? Definitely starting from here, right? Point x is -2, we get y is 0. And then for every number from -2 until 2, all the y's are positive. So this portion is positive, means, or actually it is. This highlighted x values gives us all these y values. So our solution for A is from -2 to +2. Parentheses, because you don't have the equal sign. No equal sign means parentheses. And these are numbers. That's it. Not y's.
Yeah.
Negative to the 2.
So that's used by solution.
Hmm?
Used by solution.
Solution. To help you, if you want, you can write x equals. To help you, but in real life, we don't use any symbol because we already assume by default whatever solution we have means the x. Send this. Give me y value here. What's the y value here? Let's say we have a y value here, this one. What's the y value? Positive or negative? Y value. If you have a y value here, what's the y value? If you have a y value here, what's the y value? So in this portion, what is your y, positive or negative? All the y values you have here are this positive or negative? But what you're looking for, which type of y? Positive. So if you look at here, this, if you have the y value here, what's the y value, positive or negative? The y value here, positive or negative? The y value here, the y value there. See? On the upper side of the y value is a positive, on the lower side of the y is a negative. So you're looking for positive y in A. The solution is all the x value that gives us all of these y values. So what are the x values? From -2 to 8. Robert. It doesn't matter because the smaller number always have to be on the left. It's a number line. So you're taking a portion of the number line and saying only this portion of the number line satisfies this condition.
So the 0 is the y value.
Right.
0, that means.
So this is actually y equals that. We don't write y, we simply write this is
Y equals negative. Or where do we go?
0 is the y.
That's, yeah, so there
Mhm.
will be x.
So usually the normal is y equals negative x squared plus 4. And then we take out the y and you say, well, this is bigger than 0. Means y is bigger than 0.
Okay.
From here we can do b. Go ahead.
Sorry,
Go
I was
on.
just saying, you have to write solution points.
You don't have to write solution. The main idea is this. This is the solution.
You have to write equals x.
Now, I said equal x is for you
Oh,
to understand that these are the x numbers, not the y numbers, x values. So in B, you're looking for the negative y's. For the same graph, for B, you're looking for negative y's. So we already seen all of these are negative, right? All of these are also negative. So which x values gives us all of these negative y's? Definitely negative infinity until -2. Huh? Negative infinity to -2. Parentheses, because we don't have the equal sign, u, and then we have these y's, so positive 2 to infinity. That's it. We had the same question, same graph, but two parts, A and B. We have the same graph. Yeah.
Oh,
It's the same graph, but two things I'm asking. Where it's positive y and where do you have negative y? So positive y is happening for these x values, negative y is happening for these x values. So you need to examine only one of them, not two of them. But I'm showing you how they're connected, how they're related. Okay. It depends on your graph, what type of graph you have. Here is upside down, so our positive is happening in the middle. But if it is upward, then it's other story, right? That's why you have to draw the parabola first. Actually, let me modify it a little bit. Let's say this is positive, so that I can answer about positive x squared. Basically, it's x squared minus 4, okay? Let me do it. Let's see it new to see x squared plus 4 bigger than or equal 0, and x squared minus 4 less than or equal 0. So right now we have the original x squared, right? So we have only one transformation, plus 4. Which direction? Up 4. And here we are going down 4. So we have our original x squared, we are moving 1, 2, 3, 4 up here. And for this one, the original, we are moving 1, 2, 3, 4 down, and we are drawing the graph. Right? We use transformation. We didn't do any math transformation. So in transformation, we only know the answer for this question. What we are looking for. Bigger than or equal 0 means what? Y can be 0 or y has to be positive. Two things. Now, where do you see y is positive or bigger than 0? For which x values you see y is positive or 0? It's in front of you guys. That's wrong. For which x values you see y is positive? For this x, is y positive? For this x, is y positive?
For all of them?
For all of them. It doesn't matter which x you take, y is always positive. So what is your answer? What is the solution? Only one infinity? Remember, it's an interval. So our solution is negative to positive infinity. Means it doesn't matter. Huh? To this? Because you are crossing x-axis. When you cross the x-axis, you want to know where you are crossing. Did you cross the x-axis here? So do you have an x-intercept? No. When you do not cross, you already see your solution. So which x gives you the positive y? All the x's. How do you write it? Negative to positive. Because it's an interval. And see, we have the equal sign, but still we have a parenthesis. Because infinity is a symbol, not a number. Infinity doesn't get a bracket. It's a symbol. Now a different story is here. Right? We are crossing the x-axis, so we need to know our x-intercept. That means you have to solve for x. So x squared minus 4 equals 0. And then plus 4. Before we subtract, we minus is because it was minus. Yeah, our x is already positive, so why don't you subtract? Just move your number 4. So we have x squared is 4, square root, the x is plus minus 2. So what is this x-intercept? -2. And how much is this x-intercept? +2. So now we have all the information we needed. So we go and see what they are asking us to find. Less than or equal 0, what you're looking for. Go ahead.
You always put the plus sign.
You're taking the variable, square root of a variable. You're taking the square root of a variable.
Right, so that's.
Anytime you take the square root of a variable, your number has 2 choices.
The two, like, the two squared.
Both of them are 4.
Okay.
What I was talking about, Robert? Huh? Louder, louder. Point in the center, because here are moving 4 units down. We are taking the original parabola from the 0, 0, and we are moving 4 units down. So original parabola was this one, right? Using transformation, we want 4 units down. So this is our new center, new vertex. Huh? For transformation, yes, you have to. But for solving here, you don't have to. But I'm using transformation to solve. In your exam, you have a solving question and transformation. For transformation, you must show your what. And for solving, you don't have to show the what. You only need your intercepts. Less than 0. So less than 0 means what you're looking for. Y is either negative or 0. 2 types of Y you're looking for. Okay, so let's take this part. What is our Y here? Positive or negative? Positive Y. So can you take this side? How about this side? Y is positive, so you cannot take it. How about in the middle? Y is negative. And you're looking for negative Y. So from which x value to which x value, all those x gives us this negative Y. Starting from which x? So you take -2. Then for every x, we have a negative. Every x, we have a negative until +2. So what is our solution? -2 to +2. And what is our boundary? Bracket or parenthesis? Bracket, because it's equal. When x is -2, we have a 0. And you're looking for 0, y. So both of them gets bracket. But what, Leandra?
No, only thing
When x is -2, we have our y 0, right? And you're looking for when y is 0. So we have to take -2. And then every number after -2, no, before -2, like -1, we have a y here negative. 0.5, we have a y negative. 0, y is negative. 0.5, y is negative. 1, y is negative. And then 2, y is negative. So everything at 2, y is 0. So -2 and +2 gives us 0 y, and everything between them gives us negative y. And you're looking for both of them. Where our y is negative and y is 0. So taking everything from negative to positive 2, including negative and positive.
Parentheses, negative can be negative bracket.
So you are taking a number from here if you put negative 3. Let's say you're taking negative 3 here. For this negative 3, what is your y? Positive, right?
Yeah.
Are you looking for positive y?
Am I
Are you looking for positive y?
because of
So this is telling you what y you're looking for. So you look at your graph and see where your y is, what they're asking for. And then based on the y, you take the x, all those x's as an interval. Let's say we have no, this one doesn't matter. Yeah. I think we'll have examples. Let's do this too. Negative x squared minus 4.
so it's upward like 2 times
Down 4. And both of them are same. So the original one is here. And you're reflecting that 4 units down. 1, 2, 3, 4. And the same graph for both of them because they're the same function. What are we looking for in the first one? Bigger than 0, which type of y? Positive y. And what you're looking for here? Negative y. For the same graph, we are seeking two questions. Why it's positive and why it's negative. So for which x value do you see positive y? First of all, do you see any positive y in this graph? So do we have any x value that makes the y positive? No. So what is our answer? Good job, no solution. My morning class is 0. 0 is a number, it's not wrong, it's not right. Our solution is actually no solution at all. What you're looking for here? And what does greater than 0 means? Positive or negative? Do you, and what type of y you get here? Positive or negative? So see, in here, all the y's are positive. And in here, all the y's are negative. But you're looking for positive y, there's no positive y, so no solution. The next question is asking where our y is negative. So where our y is negative? Everywhere, right? In the entire graph, our y is negative. So the solution for this is the entire axis, negative to positive. Because you're looking for negative y, all this y you see is negative. So you're observing y, but giving them the axis. Is it clear? Now let's say we have this. We don't have any negative sign, but we have a +3 inside the square. Which type of transformation? Left 3. And if you observe, we have the same question again, but you're looking for two different pieces. So the original XY is here, and we are shifting this 1, 2, 3 units left. Huh? Left, right, they don't follow the direction. Plus should go right, but it doesn't go on the left. Minus should go on the left, but it doesn't go on the right. Opposite. Left, right is opposite, but up, down is same. Okay, Madison. The original one we are shifting. The original is always at the 0, 0 at the origin. And that's why in your exam in the transformation, there's 1 point for drawing the original one, and then other points for your shifting, depending on which type of shift you have. So for the first question, you get this 0. Which y things you are looking for? Only the positive y. Are you looking for 0 y? No. So is there any part on the graph, do you see where y is 0?
Yes.
Where?
But
Get down. Here our x is 0. That means we cannot take that point. Besides that point, we need to take everything else. So we have a left part and we have a right part. So we have to divide our parabola into two pieces. The first piece is here. Which x values gives us this piece? Left. Negative infinity until 0 is here. Negative 3. This is negative 3, right? We shifted 3 units to the left. So negative infinity to negative 3. And negative 3 gets what? Bracket or parentheses? Parentheses because we don't have the equal sign. The inequality doesn't have equal sign, means parentheses for the number. And then we have another piece after 3. We cannot take 3 because 3 gives us 0y. But we are not looking for 0y, we are looking for strictly positive. So which x value give us the second piece? This right side. Starting from which x value? Negative 3. I thought you said negative infinity. Negative 3 until positive infinity. Because when x is negative 3, what is in y? 0. But are they looking for 0 y? They are looking for only positive y. Yeah, negative 3, but parentheses. Parentheses means we cannot take negative 3. Parentheses means not included. Bracket means included. Look at your graph. This portion is going on forever, right? So interval has to be infinity. But the question we did before. For example, here, we are looking for only the middle portion. So can you have infinity here for the middle portion? No, it is limited. It's a portion only. But we have to be infinity for this portion because this portion is going to fall apart. And also here the answer is this portion, you have infinity. So if we have continuous graph, it's infinity. But if you have a limited portion, it's just a number. Leandra, who raised the hand? Go ahead. But we have to find it, the graph already giving us the y-intercept. When you don't see your y-intercept, I mean, when you don't know what is your x-intercept, you have to find it. For example, here, we know we are crossing twice, but do you know how you're crossing? Which experiments?
You know you're crossing because x.
No, because we know we are moving the parabola 40 degrees down. See, just because you have an x square, it doesn't mean you're crossing twice. For example, here, this also have a square, but are you moving twice? Are you crossing twice? No.
So basically you kind of roughly graph it first.
Just graph it fast, and then if you're crossing twice, you need to know where they're crossing. If it's crossing once, you already know because you use transformation.
Yeah.
And if it's never crossing, you don't even need to bother about the x-intercept because it's never crossing, like that example. So here is a final example. So we have parabola, but we cannot take as negative to positive infinity. We have to break it down into -3 because they're not looking for -3. They're looking for all the positive ones. Now this question. What are we looking for here? Less than 0, -y, and equals 0, right? 0y. Either our y is negative or equals 0. And you have the same graph. So question number 1, do you have any negative y? No. But do you have any y which is 0? So which x value gives us 0y? -3. So this one has only one solution. Our solution is -3. And you know, these intervals are weird. When you have only one number in the intervals, you neither use bracket or parentheses. You have to use your curly bracket, which you learned at the beginning of the semester. Do you guys remember? When you have only one number in a set, it's curly bracket, otherwise bracket and parentheses. So for one number, it's curly bracket. Starting from here, which type of y you're looking for? Less than 0 means -y. And equal 0 means 0y, right? Where y is 0 or y is negative. So y is negative. Do you see any y value in your graph which is negative? No, because it's lying entire above the x-axis. But do you see any y value where the y is 0? Our y is 0 here, right? So which x value gives us that 0y? When x is -3. When x is -3, our y is 0. So this question has only one solution when x is -3. When x is smaller than -3, y is positive. When x is bigger than -3, y is positive. For every other x value, our y is positive. Only one x value makes the y 0. And there is no x value which makes the y negative. So a solution may have only one number, may have two intervals, or may have only one interval. It depends on how your graph is. So what? if you're crossing the x-axis. Are you crossing the x-axis here? No. So you'll have to solve for x. Are you crossing the x-axis here? Don't solve for x. To solve for x only when you're crossing. No, it depends on what you're looking for. The negative positive doesn't depend on your parabola. Negative positive depends on what you're looking for. Always, everything depends on what you're looking for. So step one, graph it. Step two, look what you're looking for. Based on what you're looking for, if you have a portion that is continuous forever, you have a negative answer, you have infinity answer. But if you are looking for something in the middle, you have a limited. It's a small portion, no infinity. So all these examples we did is to prepare you for this question, for this type of question. This type of question will be in the final exam, as well as in the exam you're going to take. What's the first thing you notice here? 2x's, and something is missing, right? 0 is missing. So what is our first step? We need to see 0. So subtract 10. So we have x squared minus 3x minus 10 bigger than 0. Our goal is to graph this. But we can't do this transformation anymore. Right? Because see, here we can see the transformation. All these examples we did so far, did you notice all of these are transformation, 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 transformation? But is it transformation? It's not transformation. It's like actual parabola. So it's not in standard form, it's in general, it's in standard form, not in vertex form. Since we are not going to use transformation, so we have to use the x-intercept to graph it. So step one, find the x-intercept. Factoring. So which two numbers multiply to negative 10 combine to negative 3? Negative 5 and positive 2. So to find the x-intercept, we set y to be 0, right? In other words, x minus 5, 0 and x plus 2, 0. That gives us x equals and negative 2. So we have negative 2 and 1, 2, 3, 4, 1, 2, 3, 4, 5 here. So we found our x-intercepts where we are crossing. Now we have to know which is parabola, upward or upside down. Why? X squared is positive. So we are going to draw an upward parabola that crosses the x-axis at negative 2 and positive 5. So negative 2 and positive 5. And this time we don't care about the vertex because we're not using transformation. We have no idea where the vertex is and we don't care. With this one, I just guessed it. Here's the vertex, I don't know. I just guessed it. The main idea is we have an upward parabola with x-intercept negative 2 and positive 5. No, because you're solving inequality. Now we are looking, question? This one will be in the exam. Now let's see what you're looking for. Greater than 0 strictly, right? Positive y. So which portion of your parabola gives us positive y? Do you see positive y here? Do you see positive y here? Do you see positive y in the middle? So since our solution is lying on the continuous portion, so will you have parentheses in, will you have infinity in your solution? Yes, because continuous. It's continuous forever. So this portion we get from these x values. Negative infinity to negative 2. Infinity always get parentheses. But how about negative 2? Bracket we use if you have an equal sign. Parentheses. And then this portion is also positive. So these x values gives us the right portion. So where do you start your right portion? At 5. So union, Whole means parentheses. Solid means bracket. Because you're not looking for y equals 0. We're looking for only which x values gives us y positive. If you take this number for x equals negative 2, your y is 0. But you're not looking for 0 y, you're looking for only positive y. So you cannot take negative 2 in your solution. Negative 2 will make the y 0, which you are not looking for.
Yeah, okay.
Negative 2 is here, positive infinity is here. So you have a problem. From negative 2 to 5, your y is negative. But you're not looking for y. So here, the smallest number you have on the left side is negative. If you draw this line forever, what will be the leftmost number you have on this line? On the left. Negative infinity. So it's like this. Here we have negative 2. Here we have negative 3, negative 4. If you keep going on and on and on forever, what will be the smallest number you have here? Negative infinity. Why you keep saying infinity? Infinity positive, it is on this side, here. Positive infinity is on this side. And negative infinity is on the left side. So we are taking all those x that makes the y negative, makes the y positive. So this x makes the y positive, we take it. This x makes the y positive, we take it. This x makes the y, all of these are positive y. So all of these x values you see, they give you positive y. So what is the smallest x you can take here? Negative infinity. On the left side is always negative infinity. On the right side is always positive infinity. So you look at your y, where the y is positive and where the y is negative. Y is positive in this portion, and this portion is going on and on and on forever, right? Same thing, this portion is positive. Your y is going on and on and on forever. Since it's going on forever, so your x also going on forever and ever and ever and ever and ever. So what is the highest x you can have? Infinity. And where you're starting your journey? At 5. So 5 to infinity, but 5 makes it 0. We cannot have 0. You're only looking for positive. So 5 has to have a parenthesis. Same thing here. You have negative infinity to negative 2. Both of them are parenthesis. What is the smallest x that makes the y positive? It's negative infinity. Until which x value? x is -2. We'll have, but not for parabola. For parabola, we have only bracket or only parentheses. For parabola, it's never 3. Parabola is always 2. Why do you have 3 of them? Something like this. Here. We have 3 x-intercepts, we're going to have more intervals, not 2. For parabola, it's either upward or upside down. And then depending on how you're crossing, you have either 2 intervals versus 1 interval, and then 1 interval versus 2 intervals. So either a solution set will have either 1 interval if it's in the middle, and it will have 2 intervals if on the left and right. So you can never say, is it always like this? No, there is nothing always like certainly. Depending on what they're asking for, either you're taking the middle part or you're taking the 2 ends. If you're taking the 2 ends, it's always infinity to your x-intercept. But if you're taking the middle part, it's only the between 2 x-intercept. That's it. So yeah, in the exam, I'm going to give you, it's final and so in the exam, something like this. Hmm? No, you're not doing the right one right now. I'm going to do it after the exam. What I want to show you next is something that will be in the exam. So yeah, I thought I'm going to finish everything, but I couldn't finish in your class, no problem. What I'm going to do now is final exam question. You will not be in the final exam, but we are going to cover them after the exam.
But it's gonna be in class.
That's why I'm skipping them.
Okay.
Let's start with this one because in the exam we're going to give you this one. So it's a solve for x or solve the triangle. What type of triangle are these? And when you write triangle, something clicks in your mind, right? Which formula? What's the formula? What is C? C means what? Good. So C is always the longest side, always. A, B doesn't matter, but C has to be the hypotenuse, the longest side. Longest side. So let's say this is A and this is B. So x plus 2 square plus 3 square, 2x plus 1 square. So we set it up, the first thing, and now all you have to do is solve. What do we do with all these squares? FOIL and FOIL. So x plus 2, x plus 2, 2x plus 1, 2x plus 1. And then we have x squared plus 4x plus 4 once you FOIL. Let's do together for them. For x squared plus, it will be 8x altogether. So not 8x. Correct. That's why we got something weird in the morning class. 2 times 3 is 4. So 4x squared plus 4x plus 1. Oh, man. Okay. So this gives us 13, we know. And since we have a degree higher than 2, higher than 1, how do you solve it? Anytime you have degree higher than 1, what do? Bring everything to one side. Do you remember? So this 4 is bigger, this x is smaller. Let's keep this and subtract that. See, bigger one always is a power. So keep our bigger one. Minus x squared, minus x squared, that cancel out. Minus 4x, that cancel out. And now this is 13, so you subtract 13. 13 equals cancel out. So you have 0 equals 4x and 4x cancel out. 4x squared minus 1x squared, how many x squared? 3x squared, and plus 1 minus 13, minus 12. What do you do? Plus 12. So we have 3x squared is 12. Divide by 3. And then square root x equals plus or minus 2. But we are solving triangles. Triangle cannot be negative. So we only take the x. X cannot be negative. Mohammed, there is no class on next Thursday.
Next Thursday.
I mean this Thursday, not next week, this Thursday. Yeah. No. For us. So I'm going to tell you now, wait. Because triangle can't be negative. Okay. So now I'll tell you what is happening here. I didn't notice before, but I have my final exam, my own final exam on Thursday. So I decided to take that day off to study for my exam. So I'm not going to have a review with you guys. Instead, let me tell you exactly what will be in the exam. Okay?
Yes.
I saw the picture.
I'm gonna start
Yeah. As long as you study this, you'll be fine because I'm going to give you exact format, just the numbers are different. So from question 1, the first type. And I may switch the numerators. Okay. I may switch the numerators, like maybe number here and function here. Okay. But this format. Okay. Huh?
the word.
Oh no, I'm going to have it actually. Oh, I forgot to put it there.
The one with the homework.
Right.
So it's coming.
Yes.
Okay.
So first type is different denominators. From this type, the second one, B.
So I need to.
The variation, similar type. Not same question, but same format, same type of format. Where you have a K is a fraction, and then remember you have a problem in your last exam, when K is a fraction, what to do? Make sure you know for this exam what to do when K is a fraction. You don't flip it, you put numerator on the top, denominator on the bottom. This question, obviously, complex, of course, from solving for x, the first one. And then working together, I missed it here, but I actually have it in the exam. So the working together problem we did in exam 5, exam 4,
All the second.
friends and that question. Not the same question, but same thing with different scenario. And then I'm skipping 10.5. I wanted to give rationalization, but I don't have space. Then from 10.6, this will be the first type. 10.7, type B, and D, and B combination. What does it mean? See, here is I already given to you. I'm not going to give you I, instead I'm going to give you 4 square of -2. So step 1 should be pull out your I, and here is square root of 2. Instead of I, I'm going to give you like sort of -14, something like here. So pull out your I, and you will ready here. So now you multiply this one, you're going to multiply the rest.
When is the last day?
11.
The 11th of May?
Our last day of class is 15. So 11 or 13, I don't remember, probably 11. But the latest late you can do is I think 11 or 13. I have to check. Okay. Here from BCD, they all are same. 11 or 13, I don't remember, I have to check. The latest submission. But definitely before Tuesday. Sorry, before Wednesday. For reducing the power, 4 of them. And here I don't have any coefficient, but in the exam you have a coefficient. So when you have a coefficient, you reduce and then multiply just with the coefficients. And for example here, if this is 1, then you have 2 times 1, which is 2. And then discrimination. I'm going to ask whole 3 types of discrimination. Point discovered is positive, how many solutions you have, what type, how about the x-intercept. Point discovered is negative, how many solutions, what type, and how about the x-intercept. 74-0, how many solutions, what type, and how about the x-intercept. So all of this in a chart, in a table. And then you're going to solve one of them. First, try by factoring. If factoring doesn't work, then you can try this. Yes, you can. From the weird looking, I'm going to give you the 4th power. From the inequality which you learned today, 6 type. And then we're supposed to learn the fraction, but I'm skipping it. I'm going to tell you after the exam. I'm going to show them. Then we have here, find the x-intercept, y-intercept, vertex, and graph. So we already learned today, we already revised today how to find the x-intercept. Finding y-intercept is easy. To find the vertex, it's negative b over 2a, the x value. What you have for x, replace into the function to get the y. For the transformation, something like this. We have negative and then something left, right, something up, down. So negative left, right, up, down is 3 points. For the original graph, 1 point. And then you have to state what's the vertex. For vertex, 2 more points.
We did it last one.
You missed a pass.
That's it further.
So state your vertex. You don't need any map because vertex is opposite of the inside, same outside. So 4 choose your vertex. You just have to state that and then sketch. The way we sketch so many transformation today, we're going to sketch the same thing. But you have to know the discriminants. B square minus 4ac. It's inside the square root. And then triangle. Total 19 questions. Your time is 1 hour, 30 minutes. Okay. So 3 pages, not multiple choice, 3 pages, multiple choice. Even though you have multiple choice, you are going to show the correct work and then fill the correct multiple choice. So total 19 questions without subpart, except the discriminant. Discriminant is all 9 parts together. 21st of what? No, not on rice base. On my MATLAB, it's different. Yeah, I had to open the practice file. I totally forgot they closed it. I mean, the due date was missed, so they closed it. So I had to extend it. I'll do it. After our exam on Friday, we had 2 classes in person. And then on the next Friday, I'm deciding to have a online review session. So what we are missing on this Thursday, we're going to do a review session next Friday. Online. And then we have we are going to go over practice questions, which will be in the final exam.
Okay. Okay.
My hand is hurting so badly, I don't know why. But go ahead, no problem.
So, I was thinking,